Welcome back to Grade 9 Science in the Astronomy Unit. Today we're going to be looking at Worksheet 2, just a quick reminder on how to work the simulator, and then we'll move forward to Worksheet 3 and 4. We're going to talk about one of the things that I think is probably the coolest part of astronomy next to black holes. Black holes for me is number one, but one of the coolest things in the Astronomy Unit is the discussion of the lunar phases and seasons. So let's go ahead and take a look now at Worksheet 2. And what we need to do in order to be successful on that. So today's plan is Worksheet 3 and 4, lunar phases and eclipses. And we're going to go back and take a look at Worksheet 2, the seasons, really quickly. So Worksheet 3 and 4, I've filled out for you guys so you don't have an exit ticket for the weekend. But for Worksheet 2, in order to fill out this sheet with your own personal notes, you need to click on this link. So when you click on this link, unfortunately, it doesn't take you to the SWF. So SWF is the type of file you need to download in order for this to work. But if you look across the top here, Home, NAAP Labs, Basic Coordinates and Seasons, and then Seasons and Ecliptic Simulator, okay, that's kind of what you need to click through. So if I go to NAAP Labs, so if I put my cursor over NAAP Labs, and I go to Basic Coordinates and Seasons. Okay, I'm going to scroll down to the bottom. The very last one there, Seasons and Ecliptic Simulator, I'm going to click on the right-hand side there, SWF. Okay, when I click on that, I'm going to click on Keep in the bottom left corner of my screen, where this type of file can harm your computer. It doesn't harm your computer, I promise. It's good for your Fujitsu. Your Fujitsu is just fine with it. You click on this, Seasons Ecliptic SWF, and it's a simulator. So we can open the simulator, and we can navigate around to see the position of the planet around the sun and the effect that that has on the sunbeams. So if you look at the position of the planet, you can see in the bottom that as we rotate around the sun, as we go through the months, the angle of the sun and the beams changes, and so does the sunbeam spread. So where are we on this planet right now?
We're in May, so you'd have to go back down. It's like, yeah, right.
So we're at the beginning of May. And if you look, view from the sun, right, you can see we're getting close to the point in time where North America is right at the center, right? So at this point, this is our kind of our peak season of summer, what we call the dog days of summer, right? Between August and September, that's when things are really hot. So if we look at our sunbeam spread, the view from the sun, you can see that's kind of right over the center of North America. And if you look at the sunlight angle, right, it's pretty much straight down. It's almost 90 degrees. Okay, so that kind of explains that to a degree. And you guys were to work through that for last class. If you haven't been able to access it, that's fine. You can take a look at that over the weekend. Okay. So it says, in what 2 months is the spot right at the equator? That's April and August. It asks you, why are they different in the southern hemisphere and northern hemisphere? So the seasons. So what causes the seasons? The tilt of the Earth's axis towards the sun, resulting in direct sunlight, not proximity to the sun. It's the amount of direct sunlight it gets. When the north has direct sunlight, the south does not, and therefore the summer season of the northern hemisphere in July is the winter season in the southern hemisphere. Hiram.
I don't really understand question 4, so I skipped.
Okay, so it says move the stick figure on the Earth to the top right of the page to the North Pole. Start the simulation. What months will he receive no sunlight? What months will he receive constant sunlight? So you can do this one. I've closed the simulator already, but you don't even need to move the stick figure. You can do this one theoretically. So which months of the year does the North Pole receive sunlight, and which months of the year does it not? That's basically what the question's asking. Okay. So which months does it receive no sun? It doesn't receive any sun from October to March. And when does it receive sun directly? April, May, all the way through to August.
Okay, thank you.
okay, which kind of models our summer seasons. Okay, let's take a look at today's lesson. The visibility of lunar phases. So, today we're going to work through worksheet 3 and worksheet 4, eclipses. Okay, so worksheet 3 is another simulator. So again, you're going to need to click on this link. It says turn on the show time tick marks at the bottom of the page and move the stick figure to midnight on the tick mark. So again, you're going to have to go to NAAP Labs. It wants you to go to Lunar Phase Simulator. Okay, so scrolling down from the top, it's 1, 2, 3, 4, 5, number 6. Okay. Lunar Phase Simulator, you're going to click on SWF. Click Keep, and you're going to open it. Okay. It says show time tick marks. Okay, and it says move the stick figure to midnight. Okay. Oops. It then asks us to select new moon from the moon phase menu. What is a new moon and what causes it? So, oops. So, in the top right corner, we have moon phases that we can select. We want to select new moon. And it says here 0.0% illuminated. Okay, look at the location of our moon. Look at where our sun is. The sun is over here on the left. The moon is directly in between our planet and the sun, right? You see that? So from the observer's perspective, right, when we look at the moon, we can't see it. It's not illuminated at all. That's what we get. That's what's called a new moon. Okay, so when the moon is directly in between the sun and the planet Earth, we get what's called a new moon. Okay, so lunar phases, guys, is a term that is used to discuss the phases of the moon. Okay, so lunar, anytime we're talking about anything lunar, we're referring to the moon. So the phases of the moon, and maybe we do or maybe we don't know that when we look up in the nighttime sky, the moon appears differently some days, right? Some days it's full and extremely bright. Did you guys see the moon last night and the night before?
No.
The moon was incredibly bright. We had very clear skies the last 2 nights.
Yeah, I saw that when I went
Incredibly.
for a run. It was
Yeah.
so, it was bright as hell.
Yeah, it was very bright, wasn't it? And I think the reason why it was exceedingly bright the past 2 days was 1, because we are coming into our summer season, and 2, we've had very clear skies. And also, our light pollution, typically speaking, has been reduced as of late because of our quarantine. People are going to bed later, fewer lights are turned on. That's a positive effect of our pandemic. So it then asks us to, let's go back to the worksheet. What is a new moon? What causes it? A lunar phase occurring when the moon is in conjunction with the sun, making it invisible or dark. Select full moon from the moon phase menu. What is a full moon? What causes it? So a full moon is a lunar phase occurring when the sun and moon are in opposition. So let's go to full moon now. Full moon, what we had last night. Okay, this is what it looked like. So we have our sun and we have our planet. Then we have our moon. There's a misconception here. A lot of people think that the full moon and the new moon are opposites. And I can see why. Let's look again at the full moon. Okay, so let's look in the top right corner here at what the new moon actually looks like. 0% illuminated, no light from the observer's perspective. We know from our optics unit that the light needs to reflect from this object to the observer's retina in their eye, right? Well, if we're not having any light reflecting to the retina, we're not going to see anything, right? And because all the sunlight is from back here, right, this object here will not be illuminated. The same thing's happening if we turn our attention to my face on Zoom. So just open up the video on Zoom. I'm going to stop sharing temporarily here. If we look at my face right now, the sunlight is coming from behind me, right? So if I open up my blinds again, all of a sudden you can't see me very well. If I open up both blinds, it's going to be even worse.
Facts.
Right? You just see me as a dark image. You can't see my face. You can't make it out, right? And the reason being is all of the light is coming from behind. So no light is coming from in front and reflecting off of me into the observer's retina. You understand that, guys?
Yeah.
Okay, so now let's go back to the simulator and let's take a look at the new moon and full moon once again. So we're in new moon right now. And in the top right corner, you can see that it's dark. There's no light, okay? The observer is over here on the right-hand side. We have sun on the left-hand side. So look at those rays. Those rays aren't going to reflect towards planet Earth, right? They're going to bounce off this side, the left-hand side of the moon, and bounce away, right, in multiple directions. Some of them might hit planet Earth eventually, but all you're really going to see is an outer circle at most, right? So as it rotates around a little bit, you'll see 0.4%, 1%. You'll start to see a little bit of the moon starting to show, right? And you can see that as we work our way around, working around. And once we get to a full moon at 100% illuminated, as a full moon, we are in the middle. The planet Earth is in between the moon and the sun. Now let's think about that for a second. There are some misconceptions that do occur. So the one misconception here is that a new moon happens when the sunlight gets blocked out by planet Earth so that none of the rays of light can hit the moon. That doesn't happen, okay? The moon is far enough away from planet Earth and the light rays are able to access the planet and the moon. So the light rays come bypassing the planet, reflect off of the moon, and the observer can see it because the light rays, the reflected rays, have been able to reflect into the retina of the observer. So that's one misconception that I want to make clear of. So some people get the new moon and full moon positions mixed up. Let's make sure that we remember this. So the full moon happens when the sunlight can reflect the rays off of the moon and back to the observer. Okay? In order for that to happen, they need to bounce off of the moon. In order for them to bounce off the moon on the side that we can see, right? Well, in order for us to see the reflection, it needs to bounce off the side that we can see. So if we're on the left side of the moon and the sun is on the left side of the moon, then we can see it. If the sun and the moon are on the left side and we're on the right side, we can't see anything because it's just all bouncing off of the far side of the moon. Does that make sense, guys? Any questions so far on that? Okay. So it asks us to select full moon. What is a full moon and what causes it? Well, what causes it? A lunar phase occurring when the sun and moon are in opposition. They're on opposite sides, 180 degrees apart. The moon is fully illuminated. How long between a new moon and a full moon? Roughly 14 days and 18 hours. It then asks us to start the animation and observe what occurs. You guys can do that. It looks for a sketch from you guys on the new moon, waxing crescent, first quarter, waxing gibbous, waning gibbous, etc. I've attached some images there for you guys, but I want you to sketch them yourselves as well, okay? Question: can you see a full moon during the day? I want you guys to take a screenshot of the app and paste it here to prove your point. Can you see a full moon? Question 6, is there any phase that you cannot see during the day? Take a screenshot to prove your point. And if you want to, you can click on this link here to see a subpage. What other factors might affect the visibility of lunar phases? So please, this is the link here. please, please, please use the simulator yourselves to answer these questions. I want you guys to work through it because I don't want to just give you the answers. If I just give you the answers, then you won't be able to fully contextualize what we're talking about. I want you to work through it yourselves and come to conclusions on your own terms. Okay, more about the moon now. So we know about the phases of the moon. We know there's a bunch of different phases, and we can see that because as we rotate the moon around our planet, because the moon orbits planet Earth, right? As it orbits planet Earth, we can see the different phases of the moon. And we see in the top right corner, those phases have names. So a new moon, a waning crescent. New moon, waxing crescent. This is the direction it moves in. So a waxing crescent, wow, say that 5 times fast. A waxing crescent begins to be visible after a new moon. Then, as the moon continues to rotate around our planet, we move from a waxing crescent towards a first quarter moon. After the first quarter, we get a waxing gibbous. So crescent is smaller than a first quarter, and gibbous is bigger. So we're waxing. Waxing is the early phases. Waxing gibbous. Then we get to a full moon. After the full moon, these phases are referred to as waning. So now we're entering a waning gibbous as we start to lose the light. Waning gibbous. Then we approach the last quarter. So now we're in the third quarter or last quarter moon. Okay, as we continue to move away, what do we think the next one's going to be? We went from waxing crescent to first quarter to waxing gibbous to full moon to waning gibbous to last quarter. What do we think this is going to be? The last quarter, then what?
Waning
Crescent.
Yeah, waning crescent. So the last 2 phases are called waning, gibbous and crescent. The first 2 are called waxing, crescent and gibbous. Okay? Last quarter, first quarter, full moon, new moon. So in transition from new moon, we go new moon, waxing crescent, first quarter, waxing gibbous. Full moon, waning gibbous, last quarter, waning crescent. New moon. Start the cycle again. Are we okay with that, guys? Perfect. Anybody know what an eclipse is?
It's when the sun, or it's when the moon completely covers the earth, or it's when the moon completely covers the light that comes from the sun.
Yeah. So an eclipse, in the case of a lunar eclipse occurs when the moon enters the Earth's shadow. Okay. The moon is not directly lit up by sunlight and usually turns a deep orange color. So some people tend to misconceptualize a lunar eclipse and a full moon, which makes sense, right? Like if we look at this simulator, let's go to a full moon again, right? It might make sense that some people may misinterpret this as potentially being a lunar eclipse because look, the sunlight's coming from here, it's hitting the Earth, then it's hitting the moon. So isn't this in the shadow? Well, no, not always, because remember, the Earth also rotates around the sun. Okay, so it doesn't always eclipse the moon, and we're going to talk about that. So a lunar eclipse occurs when the moon enters the Earth's shadow. The moon is not directly lit up by sunlight and usually turns a deep orange color. A total lunar eclipse, the whole moon is in the umbra. What's the umbra? Well, the umbra is the full shadow, okay? The full shadow of the planet Earth. The penumbra is a partial shadow of the planet Earth. Okay, so we have, if we zoom in here, you can kind of see the shading there. So you can see the umbra comes from the top and kind of angles down towards the moon, and from the bottom, it angles in towards the moon. The umbra is the full shadow. If the moon is in the umbra, it will be fully eclipsed. Okay. In the penumbra, the penumbra is the partial shadow. So a good way to remember this, guys, is umbra is the full shadow. That one you'll just have to memorize. Okay, the umbra is the full shadow of the earth. The penumbra, though, the way we can remember penumbra is P for partial shadow. Penumbra and umbra. So as the moon orbits around the sun, or sorry, as the moon orbits around the planet Earth, it can enter the umbra. When that happens, we get what we call a lunar eclipse. So the whole moon is in the umbra, and note, the top left of the moon is deepest into the umbra, so it appears the darkest in the image above. Refraction in the Earth's atmosphere does cause some of the sunlight to hit the moon, but it has been filtered by the Earth's atmosphere, so only orange light reaches the moon, which is pretty cool. Remembering back to our optics unit, that's a pretty cool little case study. A partial lunar eclipse happens when we have some parts in the umbra and some parts in the penumbra. So in this case here, in this image, a partial lunar eclipse is occurring. The bottom left is in the umbra, but the top right is in the penumbra and still appears to be brightly lit.
Okay, he fat fingered.
Watch this. Calculations. 3, 2, 1.
What's going on there, guys? Somebody watching videos in the background? Okay. There's another type of eclipse, a solar eclipse. And this happens when the moon's shadow touches the Earth, blocking the view of the sun from a small region on Earth's surface. By coincidence, the moon's shadow just touches the Earth, so this region of totality is very, very small. So if the umbra touches the Earth at a total solar eclipse is seen. If the umbra does not quite touch, an angular ring solar eclipse is seen. Annular ring is shown in the middle there. If only the penumbra of the moon touches the planet Earth, then a partial solar eclipse is seen. So some examples there of a solar eclipse. Very rare, very cool phenomena. So when do eclipses occur? Eclipses occur only when the moon crosses the ecliptic and lines up with the sun and Earth. Most of the year, new moons and full moons do not cause an eclipse because the moon is either above or below the ecliptic. But the moon's orbit appears to wobble up and down as the Earth orbits the sun. Actually, the moon's orbit is always in the same plane, but is tilted 5 degrees relative to the ecliptic. So as the Earth orbits the sun, the nodes where the moon's orbit crosses the ecliptic slowly change. So we can actually see this using this flash animation. Oh no. So you gotta click that link to get this to work, I guess. Here we go. So we can see the Earth rotating around. So you can notice we have 3 eclipse seasons. So you can see when it crosses the ecliptic plane. You see the moon crossing the ecliptic plane there? You can see as it crosses planet Earth. If that occurs, blocking the sunlight, we'll have a solar eclipse. It can occur on the other side. And when it happens on the other side, we get what we call a
Lunar eclipse.
lunar eclipse. Perfect. Well done, guys. Okay. So I want you guys to work through these worksheets and the shadow simulators. And that's what you guys are going to do for this class. No exit ticket for this class. Okay. You guys have some independent time to get caught up. No exit ticket for the weekend. Okay. So just getting worksheet 2, 3, and 4 done. let's try to get these done before the end of the weekend. We'll do a quick homework check, okay? Do a homework check on Tuesday. Sound good?
Okay.
Okay, guys.
Okay.
Have a great weekend.
So it's basically worksheet 1 to 4.
Well, you today's in class is worksheet 3 and 4, but at this point now you should be by the end of today's class you should be done worksheets 1 through 4. Yep.
Okay.
Okay. Sound good, guys?
Thank you,
Yeah.
Mr. Gate.
Thank
Cool,
you.
guys.